Okay, we have a vernier caliper here. So we have the main scale on the bottom and the vernier scale on top. So how do we read the vernier caliper reading? We will start from the 0 on the vernier scale. So this is the point that we are trying to read. So on the main scale, we can read up to this division. So this is 2, this is 3. So each division should be 0.1. So we have 2, 2.1, 2.2 and 2.3. However, we still have a last portion here, okay, to make up the last digit of the reading. Okay, how to get this last digit right? We can read the vernier scale. So we see which division on the vernier scale forms a straight line with the division on the main scale. So we look at 1 doesn't, 2 doesn't, 3, it forms a straight line. So this is the number that we are looking out for. So it should be 2.33. Answer C. Okay, we are given a distance time graph here. So we need to recall that the gradient of the distance time graph will give us the speed. So we can divide this graph into 3 portions: x, y, and z. Okay, for x, right, we see that the gradient is increasing, so the speed is increasing and the car is accelerating. Okay, for y, we see a straight line, so the gradient is constant, the speed is constant. So there is no acceleration, is equal to 0. At z, the graph is horizontal, that means that there is no increase in the distance. So the gradient is 0, the speed is 0, that means it is at rest. Okay, now let's look at the options. Option A, at x, the car is not accelerating. Okay, this is wrong because the car is accelerating. At y, the car has uniform acceleration. This is not right because acceleration is 0. The car is not accelerating. C, at z, the car has uniform speed. This is wrong because the car is not moving. D, at z, the car is at rest. Okay, so this is the answer, D. We have a speed time graph here. So we can divide this speed time graph into 3 portions. Okay, from 0 to 20, 20 to 40, and 40 to 50. Okay, from 0 to 20, the speed is increasing at a constant rate. Okay, so this is equivalent to constant acceleration. Okay, from 20 to 40, the speed is constant. Okay, it's a horizontal line, so this is constant speed. From 40 to 50 seconds, right? The speed is decreasing at a constant rate, so we say that this is constant deceleration. Okay, so now look at the question. What is the distance traveled by the car during the time when it was moving at steady speed? Okay, steady speed meaning we are only concerned with the middle portion from 20 to 40 seconds constant speed. Okay, so now we want to find out what is the distance traveled. Distance traveled is also the area under the speed time graph. So what we need to do is to just find the area of this shaded portion. Okay, that will be 10 times 40 minus 20, 10 times 20. That is 200 meter. Answer C. Okay, let's recall Newton's second law. That will be resultant force is equal to ma. So that means that the resultant force is directly proportional to the acceleration. So the larger the acceleration, the larger the resultant force. So in this case, we want to find out which object will have the greatest acceleration. We just need to find which one has the largest resultant force. Okay, option A, the resultant force is equal to 80 plus 20 because they are acting in the same direction, so we add them up. So we have 100 Newton to the right. Okay, option B, we have 80 and 20 Newton acting in opposite direction. So that will be 80 minus 20, we get 60 Newton to the right. Okay, option C, the resultant force, it will be 80 plus 40. It will give us 120 Newton going to the right. And option D, we have 80 minus 40, we get 40 Newton going to the left. So the largest resultant force here, it will be option C. As the driver's foot presses down on this pedal, it will cause a anti-clockwise moment. Okay, so this anti-clockwise moment that is caused by the driver's foot, right, is force times distance, so it will be 20 times 40 cm. That will give us 800 Newton cm. And we find that this anti-clockwise moment is transmitted to the piston here, so there will be a force to turn to create a anti-clockwise moment of 800 Newton cm as well. So down here we can calculate the moment. Here is 800 is equal to force times distance. So the force that will be produced, we don't know. Let us represent it with F, and we multiply by the perpendicular distance to the pivot of 5 cm. This force will get 800 divided by 5, we will get 160 Newton. Okay, answer D.